We are going to start next chapter in our today's class. That is our chapter number 6 in class 11, volume 1, physics. So that is only called as system of particles and rotational motion. So in our today's class, we are going to study what is the types of motions and what is the introduction, like what is this rotational motion and how the bodies will be and all. So till now, you have studied 5 different chapters like physical quantities and measurement, motion in a straight line, motion in a plane, and as well as next we studied Newton's laws of motion. I think one more chapter we studied. Anybody? Portion laws of motion. Next one, for those. What are the 5 chapters we studied till now? Everybody, physical quantities and measurement.
Touch.
Yeah, vectors. So that vectors only second chapter. So laws of motion is the one last chapter what we studied, and previous chapter we studied motion in a plane, and then motion in a straight line, and then units and measurement. So totally, this is the 5th chapter, 6th chapter. 5th chapter. Totally 6 chapters or 7 chapters, Pradosh? So only 7. So this is totally we studied till now 4 chapters. So this is the chapter number 5. And work and energy and power also we studied. So totally 5 chapters we studied till now. Am I right, everybody? Correct?
Yes, sir.
So now this is the 6th chapter, system of particles and rotational motion. And remember, this is the one of the most important chapter and big chapter also. So compared to last 2 chapters, this is one of the big chapter. And till now, whatever you studied, like system of motion in a plane, motion in a straight line, work energy and power, all the things, if you combine, that is what is this is the chapter rotational motion. We studied like acceleration, velocity, displacement, distance, when the body is traveling. So this all the things will be coming in this chapter. So that is what rotational motion. And this is one of the biggest chapter and most important chapter for your NEET and as well as JE. And typical chapter also. Compared to all these chapters what we studied previously, it has more importance also. So that is why in this chapter, you need to understand everything very carefully. If you have even a small doubt, you can ask me. And we'll proceed very slowly, very clearly. By this month end maximum 100% we'll finish this. And we'll go to the next chapter also. So let us understand first introduction of this thing. So system of particles and rotational motion. So we all knows that you might be studied. First, what do you mean by rotational motion? So that is what is very important. So rotational motion means in the sense of this is what is about rigid body dynamics. So we all knows that kinematics means we studied like Newton's laws of motion, that the force and like motion in a straight line and all, how the body is traveling and all. So this is what about dynamics. Dynamics means what? Cause. Who makes, what makes, how it makes. So that is what we used to call as dynamics. So rotational motion means it's all about properties of rigid body dynamics. So let us understand first, what do you mean by rigid body? Rigid body. So basically you might be studied that properties of solids, liquids and gases. One of the property of solids, they are having a rigid structure. Basically, their solids are rigid in nature. That is what you might be studied. Am I right, everyone? Mr. Narayan? Yes. So what do you mean by rigid? Rigid in the sense of, let us, you might be studied lower classes. Rigid means like a permanent structure. The shape of the body does not change. They're having a fixed shape. So fixed shape, the objects who is having a fixed shape, we used to call as rigid bodies. So basically, generally solids are rigid in nature. That is what you used to study that. So now what do you mean by rigid? Let us understand. For example, I will take a particular body. So let me take some body I have taken. So there is a particular particle. That is what system of particle we can say. So the particle name is A, and another particle I'm choosing, that particle is B. Your choice. Wherever you want, you can choose. So the distance or displacement between them is, let me take S. So the distance between the particles A and B, I am taking as a distance or displacement is S. So if we notice it, I can rotate this body, I can throw this body, I can, whatever I want, I can make the body to like fastly, I can move it, I can throw it somewhere and all. Wherever I can done, when we can say rigid body, all of you observe, the distance between 2 points, which points they are inside their present, that is what we used to call as two internal points does not change, is only called as, what was to call everybody, is called as rigid body. So I hope you all understanding. So rigid body in the sense of whose like internal points always remains constant in the same point. So that is what we used to call as, what is to call everybody, who is to say rigid bodies. Okay, the distance between the 2 points, any points, not only AB, I will choose, suppose this point is C and this point is D. So whenever the body is in a motion, the distance between these 2 points is not changed, then that is called as a rigid body. So you can take examples of rigid body. I can take a rod, I can take a cylinder, I can take a sphere, so, or I can take a disc. These all are examples of rigid bodies, where always the distance between any two particles is internal particles, points, does not change. So that is what we used to call as what bodies, everybody? We used to call as rigid bodies. Understand, Amma? All of you clear? Yes, please. So now,
Yes,
let us understand in this rotational motion, the first type of motion which you want to understand is translational motion. So class 8 you might be studied, and again now only you are going to study in class 11. So what do you mean by translation motion? So let us understand, all of you. First I will explain it with the diagram, and then we'll write the definition. Mark, somebody called to that Manya and Samya and somebody. Okay. So all of you observe, I will take some random shape. Okay. So I'm not choosing getting any shape. Okay. So let me choose some random shape here. Let us choose this one. That is better. So it is some random shape. So now you all of you observe, I'll choose. Just I'm taking, guys, this shape, your choice. You can take any rigid bodies. So I'm choosing a 2 points now. The point, this is the point A, and this is the point B. Clear, Pradosh? And let me take the distance between them is something. Now this body has been traveled. This body has been traveled into certain another position. This body has been traveled into certain another positions, where again these bodies are. This is the position of the particles. Now if you notice it, the distance between these two in this position and this position, both are how they are. All of you check it. How they are, everybody? Yes, please. So it has been traveled. It has been traveled actually from this point to this point. So now this and this both are how, everybody?
fixed.
Parallel each other. Have you noticed it, Rudreswar? The line
Yes, sir.
drawn between the two internal points always remains parallel. Always remains parallel. That is what we used to call as. That is what we used to call as. What is to say, everybody? We used to call as. Yes, please. All of you. Rigid body. That is what translational motion. So I will draw it. So you can see that this point, the body has been shifted from here to here. And again, that body point is here and this body point is here. So you can check it. So if I check it, this position and this position, both are parallel or not? Everybody, the internal points here and here, initial and final position, everywhere it is parallel. Have you checked it, everybody? So this is following, or else the path you check it. The path which is followed, it is also what, everybody? Please. The path followed is also what? All of you. It is parallel only. So that is what we used to call as straight line. So they are traveling in a what line, everybody? Straight line. So when the path is straight line, this kind of particular translatory motion we used to call as rectilinear translation motion. Okay, so rectilinear translation motion, when the line drawn between two internal points remains parallel to itself, that is what is the motion we used to call as what, guys? Everybody, the line drawn between two points. Two which points, guys? Two internal points always remains parallel to itself. So that is what we used to call as translatory motion. Understand, Mr. Prados? Clear?
Sir.
Yeah. So now, for example, so if the path is straight line, we used to call as what, everybody? This is only called as rectilinear translatory motion. Now, let us take one more kind of things. I'll make you. So please, all of you observe. So let me take, this is the body. All of you clear? Everybody able to understand? So now I have taken this body has been traveled. Check it, everybody, how I will make it. So I want, there is a shape, I want to check it, whether it is there or not. Okay. So let us take, this is the shape. Okay. So all of you observe like a railway track. We all people knows railway track we people make. Am I right, everyone? Yes, what is this?
Yes.
Yeah. Okay. So let me take, I'll draw with the hand. So all of you observe very carefully. Railway tracks and all you can see, they will not be always in a straight line, but definitely the distance between them is always, at any point, the distance between them is always remains constant. Am I right, Mr. Pradosh? Rudreswa? Suppose the train is traveling in this track, correct? So now I have taken a body whose point, internal point is, let me take this point is A and this point is B. Okay, well, you can check any point. So I'm drawing a 2 points I have joined. So it is containing many points. Am I right or wrong? Everybody, please respond. All of you. So it has been chosen a path in such a way you can see. So this is the path it has been reached. Clear, everyone? Now, finally, the point is here. Now, again, this point is A and this point is B. So if I notice it here, so is there any distance is changing between the points? Anybody? Distance
No,
is
sir.
not changing. Am I right or wrong? And also you can check it. So both are parallel to each other. Initial position and final position is parallel. So path is parallel. Path parallel. How's are parallel? You can check it. Now you can notice it. These particles, the particles, particularly at this part I take, here they will start moving downwards or upwards. These particles, entire body, you can check it. They will start moving what direction? Downward direction. Am I right or wrong? Everybody, please respond. All of you. Yes or no? Each particle will travel and again it is going right. So the same particle will start rising up here. And here also the same particles will start rising up here. So the path is actually a curved path, but finally they both are initial and final, they are in parallel to itself. So the path is parallel, if you notice it, everywhere the path is parallel. So then, but it is a curved path. That is why it is called as, what motion we used to say, everybody? We used to call as curved motion. And it is a translatory motion. Particle, the distance between the particles, you can see. The line drawn between the two internal points always remains what? The two internal points always remains parallel itself. So that is what it is called as curvilinear translation. What is to call, everybody? It is called as curvilinear translation. Are you clear, Amma? Understand? Everybody. So translation motion is two types. One is rectilinear translation. Second one is what, everybody? Curvilinear translation. So first, what is translatory motion? Whatever it is, either it is a rectilinear or curvilinear, doesn't matter. You should remember that the line drawn between two internal points always remains what? Everybody? Remains parallel to itself. So this kind of motion we used to call as what motion? Everybody? We used to call as translation motion. Understand, Gamma? Clear, everybody? Respond.
Yes, sir.
Yes,
That
sir.
is one. Next, second type of motion. This is what is very important. So please all of you observe. The second type of motion is rotational motion. Rotational motion. Now, let me take some rigid shape. All of you observe. So our choice. So this is what the rigid shape I have taken. Check it, everybody. So now you all can notice it. So imagine that the entire body is rotating about a fixed point, like a fan. So that is what is axis of rotation. What is to call, everybody? That point is called as what? Axis of rotation. So that is what is a fixed point. Rudreswar, can you able to catch it? Means this is the fixed point. This whole body will start rotating based upon that fixed point. That is what we used to call as pivot point. Means based upon a particular point, entire body will start rotate. Based upon the fixed point. That is the point we used to call as what point, everybody? We used to call as? Yes, please. Pivot point. Understand, Amma? All of you? Please respond.
Yes.
Now, imagine there is a particles in this one. Let me take this particle is A. Now, there is another internal particle which I am considering as a B. You can consider C also. Another internal particles C. Another internal particle some X. I don't know. Now, about a fixed axis. Remember, these all the particles, B particle or C particle or X particle, they all will rotate. They'll make in a circular path about a what point, everybody? About a what point? About a fixed point. Clear, everybody? So there is a fixed point in the object where whole body will revolve or make a circular path, circular motion around this fixed point. So that is what we used to call as pivot point. What we used to call, everybody? That particular point we used to call as pivot point. Understanding how? So now let me join all these internal particles. So just imagine I have joined all the internal particles. Now imagine that this B particle will start rotating. It has been came to somewhere this position. Now the C particle also somewhere came into this position, rotation. And X particle also somewhere came into this position. Imagine that. I will redraw the diagram. It is revolving. Understand, Rudreswar? So now imagine that if the pivot point is a fixed point, so that now same shape exactly how to try to draw. So I will try to maximum, I will try to draw exactly, but if it is similar to you, try to draw. So now the position of the body will be changes into like this. Will you all agree with me, everybody? So of course, a shape is maybe not similar, but this is what it is. Rotating, guys. Are you understanding?
Yes, sir.
So now if you check it from the fixed point, okay. Let me take this is the C point and this is the X point. So now if I draw these all the points from the A, imagine that. Okay, I will erase that and I will draw. Now if you notice it, check it here. Imagine this is what the midpoint. So axis I have taken. So this is the point B reached here and point C reached here and point X also reached here. Now, all of you observe every particle is revolving around the fixed point. Will you all agree with me? All of you? Yes? And now check it. Initial path and final path. Is it there in parallel to each other? That is what is my question. Is there parallel to each other? Path. Is it path
No,
is
sir.
parallel to each other? Respond. The line
No, sir.
joining. So that is what we used to called as rotational motion. The line joining two internal points does not remains what? Does not respond.
Parallel.
Remains parallel to itself. So that is what is the motion we used to called as rotational motion. And in this rotational motion, all the particles makes in a circular path. About a what point? Everybody. Suppose B point will make circular motion. It will be revolving and it will be coming like this. And C particle will go like this and it will make circular path and it will come like this. And X particle, it will goes like this and it will make some rotation and it will be finally coming. Understanding? Finally coming to the same point position. So about a fixed point, this all the particles are revolving. Am I right or wrong? Everybody, please respond. All of you. So this
Yes,
kind of thing we used to called as rotational motion, in which, please write, in which all particles, all which particles? All which particles, guys? Internal particles. Okay. So all internal particles makes in a circular path. For those clear? Circular path about a fixed axis. So that is what we used to called as rotational motion. I hope everybody understand, Amma. Clear, Amma?
Sir.
Okay. So they are making particularly what motion they are making. They are all revolving around a particular point. That is what we used to call as fixed point, pivot point. And they are making what motion? Anybody can tell me? Circular motion. They are making a circular motion. That is what you have to remember. Okay, guys. All of you.
Yes, sir.
Rudresha?
Yes,
Yes.
sir.
Yes. So this is what was to called as rotational motion. Now, next one, third one, planar motion. How many of you observed that ball is rolling on a ground automatically after traveling in a certain distance? What will happen? Everybody? It will comes to what? After traveling certain distance, ball
Rest.
will comes to what, guys?
Rest.
Rest. So that is because of friction. That's fine. So planar motion. What is the example for planar motion? Everybody? Example for planar motion.
Rolling.
Rolling. Okay. So let us take now. I'll take a certain number of things with a picture. I will explain. So just all of you observe. Let me draw one planar surface now. So just like a ground. Imagine that I'm taking as a ground this one. Okay, everybody. So no confusion. So this is what the ground. Let me take it as a dotted lines. So what is this, Pradosh? Surface. Can you able to understand, Pradosh? Clear, Amma? Girls?
Yes, sir.
Yeah.
Yes, sir.
Now imagine that just I want some number of rounds. So just to make it to explain you. So I'll copy that now itself. Okay. So I'll bring it here. Whenever we want, we'll take it. Okay. Now all of you observe, this is the first kind of ball which is rolling. So from the center, we all knows that any surface, let me take any 2 points from the center. I'll take it to the surface. So this is the 2 points I'm marking internal points. One point is A and another point is what? Everybody? One point is A, another point is what? B. So from the center, let me take this point is A and this point is what? All of you. B. Clear? Now imagine this ball is started rolling in this direction. Clear, everybody? In this ball is started rolling. Now, from the center always, the B point is always, of course, in a fixed position. Now A point is keep on rotating. Am I right or wrong? Everybody? Clear or not? Please respond. All of you?
Yes.
Pradosh? Clear? Now imagine that now
Yes,
the
sir.
B rotating into some other direction. So just I want to know. So let me delete this one. Okay. So I will arrange these positions, guys. Later I will draw. So imagine now I rotated so that B came. Let me arrange first itself. Again, it should not be trouble. Okay, I'll explain you. Just draw you also. So now check it everybody carefully. This is what is the positions I'm just drawing. Okay, imagine. Now after rolling certain distance, do you think that this A again not come to the same point? Will you all agree with me? The A point always come to the same thing. Am I right? Yes? All of you?
Yes, sir.
Yes or no? Please respond, guys.
Yes, sir.
So if you notice it, let me make that is also. Now imagine this A point after taking rotation from the center, it has been came here. This is what is my A point position now. So just imagine that. This is the B point and this is the A point. So after making rotation, the A point will come here or not? All of you respond. Everybody clear?
Yes, sir.
Yeah. Now you can check it. What is mean by planar motion? All of you remember. Now initially body is at AB. So now after traveling certain distance, again A will come to up or not? Everyone? All of you? A will come up or not? Yes, please.
Yes, sir.
Yes. So initially this one is at here, A point. After making certain rotations, after traveling certain distance, that is what distance. Again, this point will come or not, everybody? The same position. Oh, sorry. It will come or not? All of you?
Yes, sir.
Yes.
Yes, sir.
Now see that. So all are parallel. So I will take it as this is a parallel. Okay. Now all of you check it. Now see that when it is parallel, this is called as some motion. What motion, Pradosh? The initial point and final point is same after certain distance. What is that motion called as? You can see that B point and A point, and again this A point and B point. Now tell me. So what is this motion we can say? Parallel to each other.
Translational motion.
Yes. So this motion we used to called as, what motion we used to say? Everybody? Translation motion. Am I right or wrong? Translation motion. Now, do you think that again this A position cannot be come to this kind of position? Is it will possible or not? It will come or not? All of you. Yes or no? Respond.
Yes, sir.
Yes.
Yes, sir.
In the sense of after traveling certain distance, the body is coming into this point, this position again. So of course, it will be keep on repeating. Now, if you observe this one and this one, this also both are parallel or not, everybody? But it is rotating also. Am I right or wrong? Body is rotating. Body is rotating and as well as it is traveling what motion? Body is revolving around a fixed point. Body is completely making revolving around a fixed point. That is what the fixed point be. And each point is traveling the same distance. So that is what we have been noticed here. Now from this you can tell me. So at every particle, the distance between the two particles remains constant and they are parallel to each other, so that it is a translatory motion and it is revolving around a fixed axis. So means revolving around a fixed axis means we used to call something. What is that motion we used to say? Everybody. It is called as rotational motion. Am I right or wrong? Please respond. And each particle traveling the same distance, parallel to each other path. So that is why it is called as what motion? All of you. Translation motion. So if you fix this translation plus rotational, that is only we used to called as. What is to call, guys? Please. All of you. Planar motion. Planar motion means translation plus rotational motion. So that is what we used to call as. What we used to say, everyone? Planar motion. So please note it. Very important one. Are you clear, everyone? Mr. Pradosh, Rudreswa? Understand?
Yes, sir.
Yeah. So please write it. Make sure if you understand only you can write. Otherwise you can ask me. I'll explain it. Mr. Kadir, understand?
Yes, sir.
Yeah. So each particle making the same. You can notice it. And their traveling is also what? They are revolving around a fixed point. That is the first thing. And they are keep on moving in the another thing. Now I'll show you that one example also. So let's start seeing that, everyone. If you are okay, then I'll show you. Clear?
Yes,
Yeah.
sir.
Yeah. So
Yes, sir.
observe any shape, not only a spherical shape, any shape we can take it. Okay. So just we can watch this video and we can make sure we'll understand it. That's all it is. Just for understanding only.
By kinematics, if you recall, we mean that for now we only focus on the geometric aspects of motion. Rigid body motion by nature is
any shape. Rigid body means what is rigid body? The distance between the two internal points should not
Change.
change. That's all it is.
more complicated than particle motion because it involves not only translation but
See that Now it has been rotated. Am I right or wrong? Everybody understand, Pradosh? It has been rotated. Correct or not? Now you can take any two particles. You can notice it.
Rotation as well.
Observe.
For now, we only focus on planar motion instead of three-dimensional motion, which means that during motion, the path of any given particle in this rigid body is limited in a plane, and these planes are parallel to each other. And also, each plane is always parallel to a fixed plane, and it remains at the same distance.
Note this point. What we studied only, equidistance to a fixed plane. Understanding each plane is always parallel and equidistance to a fixed point. That is what is the only thing. So the distance between the two internal points is always remains constant.
To this fixed plane. There are three types of rigid body planar motion: translation, rotation about a fixed axis, and lastly, the general plane motion, which is simply when the rigid body is undergoing both translation and rotation.
That is what is the third type of motion. We are studying that only. Do you understand, Ra? Everyone, Mr. Monish? Yes, please. Narayan, clear? Yeah.
Simultaneously.
Yes, sir.
During translation, the path could be a straight line, which is called.
So see that the motion is a parallel. So what motion it is called as? What is it called? Translatory motion.
Rectilinear translation. Or the path could be a curve.
Now it is a curve. So that what? Still the distance is same. What is that motion called as? Still
Curvilinear.
Curvilinear motion. Because each particle, it will take the same path. Do you understand? Everybody?
And this is known as curvilinear translation. Either way, during translation, for any 2 points on this rigid body, their paths are identical. Now let's
path is identical. That is what very important. Please remember that the distance, that is what same path it will be. Each particle will follow the same path. Okay.
Same path.
Let's analyze translation using relative motion. Let's say there are two arbitrary points on this rigid body, point A and point B. Initially, there's a fixed XYZ coordinate system with the origin at point A. Then, we define another x prime, y prime, z prime rectangular coordinate system that will always have the origin at point A and will translate with point A.
See that? Now you have to imagine how many dimensions. See, remember entire three-dimensional, you have to, this rotational motion. How many dimensions you have to imagine, everybody? Yes? Three-dimensional one. Now, as we are studying virtually, my suggestion is, you all people know, I used to teach you magnetic times. 3 pens, you with the rubber bands, you make it into, how you can make it into 3 different dimensions. Okay, brothers? Make a model. I will send you the photo. Take 3 pens or long pencils, unsharpened pencils. You take it and tie with a rubber band 3 in the 3 different directions. Because this whole chapter you have to use this concept. Whenever I explain, you have to imagine that which axis it is acting. Are you clear, everybody? What I'm saying? Yes. So make a toy, simple toy to understand the rotational motion. 3 dimensions. That is what x-axis, y-axis, and as well as z-axis. 3 pencils you tie with a rubber band. So that all the 3 dimensions you can imagine as a 3-dimensional, you can make it. That is what.
Therefore, at any given time during motion, vector RA represents the absolute position of point A measured from a fixed origin. RB represents the absolute position of point B. And RBA represents the relative position of point B relative to point A. And we already learned that this relative position equals to RB minus RA. During translation, this relative position vector remains the same. Its time derivative is 0.
This and all I'll teach you, no need to worry. But that we'll study that. You just observe that.
Which means that the position of point B is always the same relative to point A. And the relative velocity of point B is also 0. The relative acceleration of point B is
this all we'll study. Evening we'll study. It's not
also 0.
Okay.
This means that for any two arbitrary points on the rigid body undergoing translation, the 2 points will always have the same velocity and
This is very important. Understand, Rudreshwar? This is, please note it. So when the body is in translation motion, keep it in mind, every particle, they have the same velocity. A particle having some velocity v, then B particle also having the same velocity. A particle having some acceleration a, then B particle also having what? Everybody? Same acceleration. So acceleration of any two particles, any internal particles of a translation motion is always remains constant. That is what you have to remember. Clear, everybody? During translation, it is not true in the rotation. Keep it in mind. Translation, it is true, but rotational motion, it is not true. That is what it is. Okay. So please make it that. Differentiation also people knows. If you want, you can write that also. Nothing wrong. We'll study that.
acceleration. You can also say that during translation,